Hey, what's going on, guys? Today we're going to do LeetCode 217 contains duplicate. The problem statement says, given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. Okay, one way we could do that is we could just go through all of the elements and check if they're equal to any other element in the array. So we can start with 1, we can check if 1 is equal to 2, we can check if 1 is equal to 3, and we'll check if 1 is equal to 1. And since we know that in this case 1 is equal to 1, we will return true. But let's assume that like this 1 was like a 4 or something, the one at the end. Then we would just move on to 2, we would check if 2 is equal to 3, and 2 is equal to the last element, and we would just check all of the elements with all the elements in the array. So gives us a time complexity of O of n squared, because as we talked about, for every single element, for every single element I, we're going to loop through the array n times, right? And there's n elements for I, so we're just going to be n squared. This is the time complexity, and the space complexity for this problem will be O of 1 space, because we don't use any external data structures, any just external storages. Next, we'll talk about a sorting solution. So will sorting help us at all? So let's just sort the input and see what we get. So when we sort the input, we get 1, 1, 2, 3. So sorting the input in this case, right, they're all numbers. They would place the same number right next to each other. So we have 1 and 1 right next to each other. So the only check that we would have to do when we run through the for loop after we sorted the array is this: we just have to check if nums of I is equal nums I plus 1, right? And if that condition ever, I plus 1. And if that condition ever passes, then we just return true and our algorithm ends there. But if we loop through the entire array and this condition never passes, then we just return false. This is a O of n log n time complexity, because we know that sorting is an n log n operation. And there's no space here either, so it's just O of 1 space. Lastly, the last method, the most optimal method, is we're going to be using a hash set. So a hash set is just a data structure that can take in these integers, but it won't store any duplicates. And the reason we use a hash set is not just because it doesn't store any duplicates, because it has O of 1 add operation and O of 1 contains operation, similar to a hash map. So let's look at an example real quick. So we have our original starting array. Actually, let's use the other one. 1, 2, 3, 1. And let's just say we have a hash set. I'm going to make it green. What is our algorithm going to look like? So we're going to store everything that's not a duplicate in the hash set. So we have 1, right? Is 1 in the hash set? No. So we store it. Is 2 in the hash set? No. So we store it. Is 3 in the hash set? No. So we store it. Then we get to this element and we check if 1 is in the hash set. Okay, 1 is already in the hash set, so we just return true and our program ends right there. If we're able to add the entirety of the array into the hash set, then we know that there are no duplicates and we return false. So that gives us a time complexity of O of n, and it's the best time complexity out of all of these methods. But the space complexity in this case is also O of n, because we are using a hash set and storing up to n elements inside of it. So let's take a look at the last two methods, because the first one, this is just a brute force method, is pretty inefficient. In the sorting way, we see that the space complexity is very efficient, versus in the hash set way, we see that the space complexity is O of n. And during like an interview, that's definitely something to point out. So now that we have the algorithm figured out, let's go ahead and write some code. Okay, so first we're gonna start off by initializing our hash set. And in Java, this is the way we do that. A hash set, we take in integers, and we're just gonna call it set, and then we're gonna say new hash set, and we're gonna go through all the elements in our num array. So what's our first check gonna be? We're gonna first check if the hash set that is, contains that number, right? Number I. If it does, then we just return true and our algorithm ends. If not, then we have to add that number into the hash stat. And if we go through the entirety of the for loop or the entire array and we don't return true, then there must be no duplicates and we return false. That's the entirety of the code, and this is definitely the most optimal way to write this. Let's run this and see what happens. It's gonna run, and it's gonna run perfectly here as well. Well, yeah, this is a pretty simple problem. I kept the video pretty short, but yeah, I'll look forward to doing more of these problems and see you guys next time. Later.